Okay, so this is the second in a series of videos where I'm talking about the Fibonacci sequence and the difference of approaching it from a base 12 perspective than from our usual familiar base 10 perspective. So in the last video, I was explaining to you how the numbers are this, even though the numbers are the same in base 10 and base 12, we see a pattern emerge in base 12 that's invisible in base 10, where the last two numbers of every number repeat after 24 iterations of the pattern. So what we're doing now is looking at that repeating pattern a little more closely, and we're giving these values their decimal values. So this is where it's really important to realize that the difference between base 10 and base 12 lies in the size of the decimal place. So we'll look at this middle section here to really get clear on that. Here we have the number 144. So in base 12, that would be, we'll put my finger over that decimal place there, and that would look like 100, but it's actually called one grow, like a gross. So one gross in base 12 is 144 in base 10. So that's exactly the same. But if we put a decimal place in there, one there, 1.44 does not equal the length of 1 in base 12. So within the decimal places, things are different. So I've put decimal places all along here, so we're talking about 144ths. So what I want to show you is something interesting that I just actually recently discovered. When we started this middle section of this 24 iteration pattern, and then we kind of go in both directions, you'll see right away 0.75 on either side of this 0, 0. Then we do this again. Here we have 0.75, and here we have 0.47. So when we add those two numbers together, 7 plus 5 is a dozen. So we carry the 1, 4, and 5, and 7 again. So those two numbers added together give us the length of 1. Then we go farther, we see both those two numbers are the same. Then the next two, again, 1 do 9 plus dec do 3 also gives us the length of 1. We continue our journey. Those numbers are the same. Then here, L do 4 and 0.08 added together give us a 1. These two are the same. L do 9, 0.03 give us the length of 1. These two numbers are the same. L do L and 0.01 add up to 1. 0.01, 01 are the same, and then 0, 0, and here it would be 0, 0 also. So there's a reciprocal balance thing here where the numbers are adding up to the length of 1 is throughout this pattern. So this is actually also the pattern for a spiral when you plot it on a Cartesian plane. So we'll just keep that in mind. Again, this is something, this pattern emerges only in base 12. These lengths are different than they are in base 10.